Okay, grade 8, we are going to be going through significant digits. It's kind of a math techie lesson, but we should be able to make our way through it. So I'm going to read the new concept. The length of this segment is 8.9 centimeters. We use 2 digits to write the length. We use 1 decimal place because the ruler is divided up into tenths. Using this ruler, we may be able to estimate the digit to the hundredths place of length, but it would only be a rough guess. We cannot estimate the digit in the thousandths place. We distinguish between counts and measures. We can count the exact number of students in the classroom or the exact number of books in the library. Measures, however, are not exact. A measure can be expressed only to a degree of precision. That's why you'll see when they build engines, for example, the tolerances, they have very, very strong ability to measure that much better than a ruler. So they have very special tools for that. To measure the segment in the beginning of the lesson, we compare its length to a standard scale and use a number of units to refer to its length. We are confident that the segment is about 9 centimeters long. We are also confident that the segment is about 8.9 centimeters long. However, we cannot say with confidence that the segment is 8.916 centimeters long because our measuring tool does not measure with that type of precision. The number of digits we use to express a measure with confidence is called the number of significant digits. For example, the length of the segment above 8.9 centimeter has 2 significant digits. So 8.9, we have the 8 and the 9, 2 significant digits. Below are the rules for counting significant digits. In grade 8, here's where it gets a little bit more complicated. Count all non-zero digits. Well, that's pretty straightforward. Count zeros between non-zero digits. So they say, for example, 10.7 has 3 significant digits. Uh-oh, I'm going to cough. Count trailing zeros in a decimal number. So 1.20 has 3 significant digits. So the person who actually measured 1.20 knows with certainty that it is that zero there. That's what makes it significant. Do not count zeros if there is a non-zero digit to the left. The number is 0.023 has 2 significant digits. Now, when I was prepping for this, that, of course, threw me off a little bit because decimal place makes it significant, but that's the way these rules work. Trailing zeros of whole numbers are ambiguous. The number of significant digits in 1200 may be 2, 3, or 4. And the reason why we've said it's 1200, right? But it could be that we know it's roughly 1200. It could be slightly less than 1200. It could be slightly more than 1200, but they wrote 1200 in order to give it a place. That's why they say it's ambiguous. But if you put it in scientific notation, 1.20 times 10 to the power of 3, then you can see that we have 3 significant digits. That they know, for example, that this number is significant. Right? So that helps figure that out. Exact numbers have an unlimited number of significant figures. So we do not count any digits when dealing with exact numbers. For example, 3 feet. If it's exactly 3 feet, it can have any amount of significant numbers. Because we could say 3.00000000000000000, and that would mean that measure is accurate up to that far, and that would say how many significant digits you have. Okay, so that really works its way through fairly straightforward. Okay, another thing, a product or quotient of 2 measurements may only have as many significant digits. So if you have 1.23 divided by 1.1, then your answer will have to only have the first digit and the second digit. You cannot have it to the third decimal place when you're multiplying or dividing. Same thing happens with the sum or difference. So if you're counting significant digits for measuring, then you always go to the least amount of significant digits. So we're going to go through our practice set, and I know I haven't written them down, but I'll write them down. For A, it says write the number of significant digits in the following numbers. So the first number that we have is 10.68. You see there's a 0 in the middle, but that is inclusive. So you can see that there are 4 significant here. What I would suggest, grade 8, is I will give this as an answer key now, but I would hit pause, try them out, and see if you're correct. So B is 0.063 liters, and that one would have 2. C is 4.20 kilograms, and you can see that that 0 has significance there. That would be 3. D has 1.609 times 10 to the power of 3. You have 1, 2, 3, 4. We have 4 significant digits there. For E, it says figure out this answer with the correct amount of significant digits. So we have 3.6 times 4.2. We have 2 significant digits here. So we do our multiplication, and we get 12, 7, 0, 4, 2, 14. So we have, when we figure out our answer, we have 2, 11, 15. So we get 15.12. But we only have 2 significant digits, so our answer will be 15. F. We have 16.4 meters over 1.2 seconds. So when we go, then we get our answer is 12, 4, 44, we get 3, 36, 8, 6, 72, and then we get 8, and you can see it's going to keep going on and on. Right, so we have the lowest amount of significant digits is 2, so our answer is going to be 13 meters per second. We're not going to count the other numbers because we only have 2 significant digits. And that one's a little different, of course, because you have that 6 after and you're wondering what to do with it. Just leave it the way it is. We only count the first 2 digits. All right, so the other one, G, is 1.24 plus 6.4 plus 5.1. You can see they're all measures of stuff that they use for significant digits. That's the big thing. They have measures. So we have 1.24 plus 6.4 plus 5.1. We get 4. We have 6, 7. 1, 6, 7 plus 5 is 12. 12.7 will be your answer. Actually, technically, you're not even supposed to. I'm just thinking on my way through. You're only supposed to use the significant digits in the end to add or subtract, because this could skew your answer because we don't know what this is. They couldn't measure this amount. It could be a little bit there. So you're only using your significant digits there. And H is the last one. 0.24 subtract 0.12, and we get 0.12 liters. And so she is solved. And that is your practice set in your lesson 117.